What's up, my calculus friends? Today we're going to get started again on our rate trainer problem. Ooh, look at that new light is on my eye now. Ooh, I don't know how much I like that. Anyways, we're going to get started on the rate trainer problem, day 2 of rate problems. So let's go ahead and give it a go, shall we? January 2025, Dr. Calvin bears witness to robots with their positronic brains being built at a rate modeled by RT equals 10 plus 6 sine pi t over 6. If you'll remember, this is the same rate that we had yesterday. At the same time, robots are being shipped from the factory at a rate modeled by ST equals 2 plus 4.1 to the 0.25 power. And I'm sorry, to the 0.25 t power. At the start of 2025, the factory had 32 robots. So you will notice that this is really similar to the setup that we had yesterday, except for we have a second rate, which would be the rate that the robots are leaving the factory. Also, don't sleep on that 32. That 32 is going to come into play, especially once we get to the rest of the problem. Just want to kind of draw your attention to that. This lovely little photography plate illustration. Dr. Calvin and the robot Herbie, which is an interesting story from iRobot. No, not iRobot the movie, but iRobot the book. So let's look at the questions now. Is the number of the robots in the factory increasing or decreasing? Similar to what we did yesterday. How many robots are in the factory at January 7? Again, that's a problem that's very similar to what we did yesterday. And then lastly, at what time is the robots in the factory at a maximum? Justify your answer. That's the new one. That's really the big problem that we're going to go after today. Those previous two are just a little bit of adjustment when you have an in rate and an out rate. So here we go with the problems now. So is that rate increasing or decreasing? How can I tell? Well, if the in rate is bigger than the out rate, then yeah, the number of robots is going to increase. The reverse of that is if the out rate is bigger than the in rate, then the number of robots are going to decrease. All that makes sense? Look at the calculator now. We've got both of those rates in the calculator under y1 and y2. We're just going to evaluate those two functions at t equals 5, or in the calculator, x equals 5. So let's start off with y1, which is the r. That is 13. I think that's the same result from yesterday as well. And let's take a look at y2, which is s. So 7.83417. Great. R is 13. S is 7.834. Since R5 is greater than S5, the number of robots is increasing at t equals 5. Remember, vice versa would be true. If R was less than S, then the number of robots would be decreasing. How many robots are in a factory on January 7? Well, this one we have a really robust solving framework for you. It should make intuitive sense that the number of robots in the factory is going to be however many robots you started off with, plus however many robots were produced, minus however many robots were shipped out. So we need to find out those three quantities. The first one's pretty easy. There were 32 robots at the factory on January 1st, midnight really. So how many robots were produced? Well, that's the integral. That's that accumulation that we talked about yesterday. Let's grab our calculator. You can see we've got that integral, which evaluates to 91.38307. Next, we calculate the integral for s over that same period. We get 44,65461. Over here on the worksheet, we'll go ahead and write how many robots were produced. Set up that integral to show how many robots were shipped out. Fill in the blank with how many robots were shipped out from that integral expression. And then we're going to write down the integral expression, basically putting everything together here. We're going to start you off with the number of robots. That's equal to 32. The number of robots that we started off with on January 1st, plus the integral that tells me how many robots were produced, minus the integral that tells me how many robots were shipped out. It's important that you're writing integral expressions because the integral expression is the calculus, and you are here to demonstrate that you understand calculus after all. Let's fill in the blanks with our numbers then, and then plug that into your calculator and get a number. There we go. I did a bunch of cut and paste over here, which is why my numbers are unrounded from the calculator's point of view. Cut and paste is always good for that. We got 78.728. Lastly, there's no space for it, but you really should be writing a summary sentence. So on January 7th, 79 robots are in the factory. Now, I know you might be thinking that maybe we should have been rounding all along the way. Maybe the answer should have been 32 plus 91 minus 44. But unless there's very specific instructions to keep rounding all along the way, you don't really need to do that. So try to follow the instructions as far as what's said and what is not said as well. This brings us to the real interesting problem of today, which is, when is the number of robots in the factory a maximum? Is the number of robots a maximum? Is that maximum actually 78? I don't know. But how do we figure that out? And this is what we call a candidate test problem, because we're trying to figure out a maximum or a minimum on a specific time interval, in this case 0 to 7. So remember from your calculus that a local maximum, or a maximum on an interval, can only occur at either the endpoints of the interval, 0 and 7, or it could occur at any critical values. Now in our case, a critical value is going to be when r is equal to s. That's when one of the rates is going to overtake the other. Or it's going to be at any place where either of the rates are, not continuous, because those are places where the rate maybe jumps. Maybe it's a break in the graph. We have seen that on the AP test before, so we would look for that. First thing is, let's use our calculator to solve when is RT equal to ST, and we're going to use the solver. So let's break out your calculator. From this screen, you would go Math, scroll to the bottom and get to Solver and push Enter. Now I've already put in the relevant equations here. You'll notice at the top of the screen it says E1 equals E2. So that basically means in this box we're going to put in the left-hand side of the equation, and on this box we're going to put the right-hand side of the equation. Since I have the left side, which would be R, already in Y1, and I have the right side, which is S, already in Y2, all I needed to put there was Y1 and Y2. You'll notice how typing those equations in Y equals saves you time here as well. Scroll down and you get to the part where it might be confusing. So what the calculator is asking for right now is which variable are we solving? And you would put your cursor over so that it's blinking next to the variable for which you're solving. So we only have one variable. It happens to be x, so we're solving for x. Now the solution isn't 7. The calculator is waiting for you to say, hey, where do you want that solution closest to? So the strategy is to pick a bunch of places to start looking and and the calculator finds the closest solution to it. So maybe a good place to start would be at t equals 1. Let's put a 1 here. And then to make the calculator solve, you would push alpha and then enter. And then the calculator is looking for the nearest solution to t equals 1. And it's taken a while. And it says no sign change. So maybe starting looking at 1 was a bad idea. Let's try a little further into our interval. Maybe we should go all the way to the midpoint of our interval. So if we're looking between 0 and 7, the midpoint of our interval should be 3.5. So well, no, not 13.5. Let's put in a 3.5, and let's see if we get a solution close to 3.5. Wow, that is not a number I was expecting. Oh, you know what? It's because I pushed the wrong button. Alpha, enter. Oops, I better put the 3.5 there. 3.5, alpha, enter. And there we go, 5.95. So the closest solution to t equals 3.5 is 5.95. Is there one closer? Is there more than one? Well, maybe we should try at 6. Why'd I put type of 5 if I wanted to put a 6? 6, alpha, enter. There's that same number, 5.9. So I'm pretty sure that's the only solution here. If you were nervous, I would definitely see about substituting 1, substitute 2, 3, 4, 5, 6, 7. The interval is not going to be so big that you can't put in multiple guesses. And if all else fails, maybe you should graph those two to see where they intersect. Here's what the graph would look like. Okay, here's R. And here's S. So you can see they only intersect at that one place, which should be that 5.9 number that we were just looking at. Let's find that intersection real quick. Calculate intersection. Are we on the blue curve? Yes. Are we on the red curve? Yes. Take a guess. Well, it was pretty close to 6. And there is that number again. So let's go ahead and write that down. Okay, next here, write an integral expression that gives the number of robots at your critical value. So let's write our integral expression. The number of robots at t equals 5.95. Well, first of all, I don't want to keep writing that number because that's a really long thing, and I'm going to waste my time if I keep writing it. So I'm going to say t1 is equal to 5.95005. Now, if I want to figure out how many robots are there at t1, so the number of robots, that's going to be equal to the 32 that we started with, plus the integral from 0 to t1 of r, minus the integral of 0 to t1 of s. Get that in your calculator. Cool. Let her rip. Great. We have 82.2258. And you would do this for every critical value that you would come up with. Also, what you're going to need to do is you're going to have to figure out how many robots are at t equals 0 and t equals 7, those 2 points being the endpoints of the interval. So I'm pretty sure that at t equals 0, there are 32 robots. At t equals 5.95005, there are 82.22581 robots. And then we're going to go ahead and calculate at t equals 7. That should be a 7, folks. So at t equals 7, we get 78.728 robots. All right, one of those three numbers has to be the maximum, and one of those three numbers has to be the minimum. And I think you can see which one is our maximum. This guy is our winner. That's our max. This is our min. Read the question. Make sure you answer what they're asking. At what time t is the number of robots in the factory a maximum? So the number of robots in the factory is a maximum at t equals 5.950. Looking good. Let's get ourselves to that check your understanding box. So to start off with, we have rates in rate R, out rate S. So if R is greater than S, then the number of objects, whatever you're measuring, is increasing, and of course vice versa is true as well. The number of objects at any time t equals t1 is equal to the integral from a to b. The number of objects at t equals b is equal to the number of objects at t equals a plus the integral from a to b of r minus the integral of a to b of s. And then finding out where the min and max is to use a candidate test. First of all, locate the candidates. Then you're going to find the number of objects, whatever it is that the rate is measuring, at A, B, and any of the candidates, where A, of course, is the beginning of the interval and B is the end of the interval. And then the maximum is going to be the maximum and the minimum is going to be the minimum. And I know this sounds crazy, but make sure you're answering the correct question. Sometimes I'll be asking for the maximum amount or the minimum amount, or they might be asking, when does that minimum or maximum occur? So answer the correct question if you're going to do these problems. Looking at check your understanding, you have the rate at which people enter the amusement park is given by E. The rate that people leave the amusement park is given by L. Both E and L are measured in people per hour, and time is in hours after midnight. These functions are valid for t between 9 and 23, and if my 24-hour time works correctly, that's 9 a.m. to 11 p.m., and those are the hours that the park is open. At t equals 9, there are no people in the park. So we're starting with letter C. Let h be that integral from 9 to t of e minus L. The value of h17 is 3,725. Find the value of h prime of 17 and explain the meaning of both h of 17 and h prime of 17. Well, the easiest one to do here would be to find h prime of 17. So let's find h prime of 17. You're being asked to take the derivative of an integral expression, and you notice that the variable for differentiation is the same as one of the variables, either the lower limit or the upper limit of your integral. So that tells us that this is a fundamental theorem of calculus problem. So the derivative is just e of t minus L of t. Now we got to evaluate this when t is equal to 17. No, you do not substitute t for the upper limit of the integral. Do not put 17 in the upper limit of the integral. Take the derivative first and then substitute 17. Didn't we teach you anything? Derivative first, then substitute. Not playing any tricks. You're putting those functions in your calculator and then evaluate. Yeah, that's a number. Maybe we should turn that into a fraction, huh? Turn that into, into a decimal. There we go, negative 380/281. So what is h? H would be, since it's the integral, the total accumulation of the number of people who entered minus the total number of people who have left the park. Now, when you consider that nobody was in the park at t equals 9, that means that h of 17 is equal to the number of people who are in the park at t equals 17, which is the same as saying at t equals 5 o'clock. So at t equals 17, the number of the people in the park at t equals 17, that's kind of redundant, is 3,725. Now the rate at which people enter the park at t equals 17 is decreasing at 380 people per hour, approximately. That looks like better English. The rate that people enter the park is decreasing by 380.281 people per hour at t equals 17. Letter D. At what time is the number of people in the park expected to be a maximum? All right. This is what we've trained for. Let's start off. This is a candidate test, and we need to figure out where our critical values are. Entering into the solver, I already have E1 equals E2, and now I just need to start taking my guesses. So somewhere, what's right in the middle of 9 and 23? I don't know. 9 plus 23 is 32 divided by 2 is 16. So why don't we try at 16? Okay, so there's my first critical value. We're going to write that down. Great, let's try another one. Maybe we should go sometime in the first half of the day, or so somewhere between 9 and 16. 9 plus 16 is, I don't know, 25 divided by 2 is 12. Let's try at 10. No, yeah, let's try at 12. What is the closest to 12? Okay, I got that 15 number again. Maybe we should try somewhere between 9 o'clock and 12 o'clock, just to be safe. I don't know, did you want to try 10 o'clock? Okay, so that got me an error. Let's try a different one. Maybe somewhere bigger than 15. Let's try 20. Ooh, 46. So clearly that's, there's not going to be any more further. So this is our only critical value. I've already labeled it as T1. So now I just need to make my table and check how many people are in the park at our 3 relevant places. Let's make our table. We already know that at t equals 9, there are 0 people in the park. What about at t equals 15.79481? I'm going to save a little space here and just do the integral of y1 minus y2. You should know that that's exactly the same thing. And we get that number, 5,867. Next, let's check how many people are in the park at t equals 23, closing time. Get that integral in shape, push enter. Whoa, at closing time, there is 1,918 people still in the park. We've got a maximum, we've got a minimum. Read the question to answer the question that they're asking. At what time does the model predict that the number of people in the park is the maximum? So they don't care how many people are in the park. They care about when does that happen. So the number of people in the park is a maximum at t equals 15.79481. Okay, everybody, that's it for us today. That was a good one. I love these rate problems. You can count on them to be there on your AP test pretty much all the time. So I'll see you next time for our next session with Calculus FRQ training. Bye.